This next lesson is on rate of change. This ties into the idea of linear relationships, but not necessarily proportional relationships. So there is a difference that a relationship can be linear in that it forms a line, and versus being proportional, which is a line through 0, 0. So there's kind of two options when we talk about linear relationships here. A linear relationship can be proportional, or it may not necessarily be proportional. What we're going to do in terms of talking about rate of change is that every single line, regardless of proportional or not, has a particular rate of change. That's why it's allowed to keep going up and over at that certain rate, which is what actually makes it to be a line then. So we're kind of looking at how one unit is changing in relationship to another, and it's really important to remember this does not have to be proportional. So over here, take a look at this first table. We're talking about cars washed, the number of cars X compared to the money Y. And what we look at when we're talking about rate of change is we're trying to figure out what's the change in your X values. In other words, X is going from 5 to 10, which is an increase of 5, from 10 to 15, and from 15 to 20, all increases of 5. The money looks like it's also increasing in terms of 40 every single time. So what we do here is we actually talk about the change in Y compared to the change in X. There's an easier way to represent this. It's with a little triangle, which actually represents delta in Greek alphabet. And delta represents the change. That's actually what this means from their alphabet. So how are the Y values changing compared to how are the X values changing? Well, the Y's are changing. They're going up by 40. And the X's are going up by 5. So basically what this tells me then is 40 divided by 5, it's $8, because this is dollars, per car. So the rate is telling me the price per car, and the rate of change here is actually $8 per car. Eventually, this is a foundational thing. We are going to use this, and we're going to actually call it another word, slope, in the future. But this is just kind of a way to start thinking about it now. So looking at Sam's saving account, let's call this X for months, Y for money saved. So what we're doing here is looking at what's the change. So 1 month is going by, 1 month, 1 month. His account's going up by $10, up by $10. Up by $10. Now, something to point out to you that if these changes do not actually end up being the same ratio, for example, 10 over 1, 10 over 1, 10 over 1, if I had 10 over 3 for one of them, it actually means that this isn't a linear relationship. So it's kind of interesting. The rate of change here, delta Y over delta X. So if we do this, it's going to be $10 per 1 month. So $10 per month. The rate here, though, is going to tell me the money saved per month. Now, one other interesting thing, if I were to go back to 0 months, what would have been his amount in here? Go back, he would have started off with $75. That's just another signal to you. We would have started 0 months, $75, which on a graph, that would be up here. And then this linear relationship would make it go up in a straight line, just like that. So that's what this graph would actually look like. Over here, we can talk about the rate of change. So if we look at the X's, 4 to 8 is a plus 4, 8 to 12 is a plus 4, and 12 to 16 is a plus 4. So delta Y for delta X. So the X's went up by 4 months. And let's look at the Y's. 21 to 22 was 1. 22 to 23 was 1. 23 to 24 was 1. So 1 inch per 4 months. So that'd be a 1/4 inch per month. So the rate of change is 1/4 inches per month. Rate tells us inches per month. And again, if you notice, this relationship would not have been proportional, but it does have that constant rate of change, which keeps the line moving in the upward direction like that.